Hi everyone. In this video, we're going to continue on with our discussion about the normal distribution. Now, if you remember from our last video, the normal distribution is probably one of the most important distributions that we're going to see in our sort of exploration of probability distributions. We'll definitely use it the most. And so there are a number of properties that we're going to want to talk about or need to talk about in order to understand the normal distribution and how we're going to use it a bit more. Now, it's going to seem a little bit disjoint about how we go about these things, and sort of there's no way around that. And so I'm sorry in advance, but hopefully you'll get each part, okay? But it's not going to flow very well, just a forewarning. The first sort of property that I want to talk about, we've talked about properties of distributions before, such as their mean and their standard deviation or their variance, and we'll talk about more. But when I mean property here, I mean more of like how we're going to use or how normal distributions are used. So we talked about the normal distribution, and then we talked about the standard normal distribution. And that's important to keep in mind here because I always denote a standard normal distribution with a z instead of an x, which is usually what we denote any distribution as. And so you'll notice here we're going to talk about something called normal critical values, and I call this normal critical value z with a subscript of alpha. And because it's a z there, that should sort of tip you off that we're going to use the standard normal distribution and not just any old normal distribution. Now, to get in more specifically about these normal critical values, these are going to seem really weird to you, and you're going to wonder why in the heck would we talk about this now? And at the moment, it does seem a bit odd to talk about them, but it turns out they're very important in what we're going to do later on in the statistics part of this course. And so a normal critical value is this point z with a subscript of alpha. And what z with a subscript of alpha, or z sub alpha, means it means it's the point on the standard normal curve such that alpha percent of the distribution lies to the right of that point. And so what we've done so far in our sort of exploration is I have always given you points and asked you to find the probability between those 2 points, okay, or greater than a point or less than a point. But I've always given you the point and asked for the probability. But in a sense, now I'm giving you the probability and asking you for the point at which that probability occurs cumulatively. And here's a picture that shows it a little bit better. So the blue curve is the standard normal distribution. It's centered around 0 and it has a standard deviation of 1, but that isn't really important right now. The 0 is maybe a little bit more important. The z with a subscript alpha is the point on that distribution. So it would be like an x value, a value of the random variable, such that only alpha percent of the distribution, which means like really alpha percent or alpha probability, lies above that point. So in a sense, if you're calculating the probability that the random variable z is greater than or equal to that point, you're going to get alpha. And so we've kind of done that. You've had to calculate the probability that the random variable is greater than or equal to a point before. And so in a sense, that's nothing different. But what's different is that I give you the probability. You need to find me the point at which that probability happens. Okay, and as you can guess here, we usually don't work with area to the right of a point. We usually work with area to the left. And so that's a bit odd here, but that can easily be dealt with by just subtracting alpha from 1. So I know there's alpha on the right. That means there must be 1 minus alpha on the left, of course, because the whole area under the curve has to be 1. That's a property of the PDF. And so we can easily deal with that. And that also means that cumulative probability is going to come in here somewhere. And another way to think about this, and it's something that we haven't gone over before, but is usually used in a probability and statistics course, is the idea of a percentile. And so we can think of this point z sub alpha as the 100 times 1 minus alpha if percentile of the standard normal distribution. So a percentile is a point such that whatever percentile you're talking about lies below the point. So in a sense, if I scored in the 95th percentile of the SATs in reading, that means that I did better or as good as 95% of the people who took that exam. And so another way to think of that in this circumstance is that if I put a vertical bar at my score and then shaded in everything to the left of that vertical bar, then that area, the part I shaded in, would be 95%. Okay? And so I can think of it as a percentile, or you can think of it as something else. Now, how do we actually calculate this? Of course, we use Minitab because we're not sort of heathens. We're not going to do it by hand. So we're going to go to Minitab, and we're going to use the inverse cumulative probability. So again, I'll show this. I have a Mac, and so it's going to show sort of in a Mac. PC is not that different, and I can show it in class. Okay, so I open up myself to Minitab here. Okay, or I open up to Minitab. I go to Calculate, Probability Distributions, and on a Mac you have these three choices. On a PC, you're going to have choices of a distribution, not of a type of probability. You'd choose normal, okay, and then you choose inverse cumulative probability. So I have to go backwards. I have to choose inverse cumulative, okay, and then it comes up with this window, okay, and so it asks you input the same thing that it always asks in a sense. Either way, if you're on the PC, it's going to look the same as if you're used to, or what you're used to. Okay, and I want a single value. The distribution that I want, the one that you want to choose for a PC, is normal. Okay, and then the mean and standard deviation need to be 0 and 1 for this to sort of work. Okay, so it needs to be 0 and 1. And then the number that I actually put in my value here is not a point on the x value, on like the x-axis. It's not a value of the random variable. It's the probability to the left of a single point. Okay, and so first, let's go back to our slides here. An example of what a critical value could be is z with a subscript, and the subscript says 0.3. Okay, so just imagine z with a subscript of 0.3. That means I want to find the point on the normal curve, the standard normal curve, that z curve there, such that 30% of the distribution lies to the right of this point. Okay, so if 30% lies to the right, then 70% is going to lie to the left. And so if we go back to Minitab, the value that we're going to put in is that area to the left, which would be 0.70. So when I click OK, it's going to give me some output here. And if you read the output, you can kind of understand what's sort of going on. It has the probability statement. Now, usually, if I do sort of a regular probability calculation like we're used to, it would say first X, and then it would tell you the probability. Now it's doing it backwards. It's telling you what you inputted, which is the probability that the random variable is less than or equal to the value, and then it gives you back out the actual point. Okay, so probability that x is less than or equal to x, I said it's 0.7 because I wanted to find the point at which 30% was to the right, which means 70% to the left. Okay, and it turns out that that point is 0.5244. Okay, so So that would be the answer there. And as your first your turn, I give you common ones that we'll see. So it turns out that all of the inference that we do in statistics really hinges on these sort of critical values in a sense. And these are common critical values that you'll see. And so these numbers that you are going to find are going to be important, and you'll see them again. But this is just an exercise in finding those points. So again, like the first one, you'd open up Minitab, you'd say normal 0, 1, inverse cumulative probability, and you'd put in the value would be 0.9. Because 0.9 is to the left, which means 0.1 is to the right, so on and so forth. So calculate those critical values for this your turn.